Okay, so now we're going to review Chapter 6. Chapter 6 was about different types of compounds and especially about ionic compounds. But first of all, you need to be able to tell the difference between ionic and covalent and metallic compounds. So just as a quick review, remember the metals are on the left of this diagonal red staircase line. So everything over here is a metal, except for hydrogen is the exception. It's a nonmetal. Okay, and then the nonmetals are over here to the right of the red line. And then there's some metalloids in here, but don't worry too much about those. I won't give you anything, and UVU won't give you anything like that. So, ionic compounds are made of a metal and a nonmetal. Covalent compounds are made of just nonmetals, so these things, and maybe hydrogen. And then metallic compounds would be two metals. So, if we look at this example, it's got aluminum, that's Al, not Ai, as some people think it is, Al. It's a metal because it's on the left of the line. And then it's got oxygen and hydrogen, which are nonmetals. So we got a metal and nonmetals, so that's going to be ionic. Now we've got C12H22O11, that's table sugar, sucrose. So we've got carbon, oxygen, and hydrogen. Those are all nonmetals. So that makes sugar covalent. And then if we've got Fe and Ni together, like that, those are both metals. So that's going to be metallic. And that's it for types of compounds. If you can do that, you're good. Okay. Other things in this chapter you need to know how to do. You need to know how to write the formula for an ionic compound. So to do this, you need to remember a few things. Mainly, you need to remember the charges on the periodic table. So remember, this column is +1. This column is +2. We skip over these guys. They're all positive, but they can have a lot of different charges. This column is +3. Skip this column. This column is -3, -2, -1. And then we skip the noble gases. They don't form ions because they're happy the way they are. They already have an octet. Okay, so to write the formula for magnesium nitrate, it's helpful to write a table out like this. I recommend when you take the final test, do a lot of work on scratch paper. Don't just try and answer the questions without doing work on scratch paper. It will help you get the right answer if you take the time to do that. So here's magnesium. It's in the +2 column, so we know it's a +2. And then nitrate. Now, if it ends in "ide," for the most part, things that end in "ide" are going to be just on the periodic table. But nitrate ends at 8. So it's going to be a polyatomic ion. So it's in this polyatomic ion chart. So nitrate is NO3, 1-. You can always look at the polyatomic ions, by the way. You would never have to memorize those. And it's a 1-. So right now, our charges are not balanced. I've got 2 positives and 1 negative. And my goal is to make those numbers balance out so that I have the same number of positives and negatives. So I'll need 1 more NO3. So now I've got 2 positives, 2 negatives. It's balanced. And then to write the formula, I just write MgNO3, and I'm putting it in parentheses to show that there's 2. Okay, you don't write the charges at all in the formula. You just write subscripts to show how many of each ion you have. All right, let's try cobalt-2 chloride. This is a Roman numeral 2, and it is telling us the charge of the cobalt, because cobalt is a transition metal, so we don't know what its charge is unless they tell us. This is not telling me that I have 2 cobalts. It's just telling me that the charge of the cobalt is 2, and transition metals are always positive. The cation, the first element, is always positive. And then chloride is the ion form of chlorine, and it's a -1. So you can see I'm going to need 1 more chloride to balance the charges out. So it's going to be CoCl2. Okay, so you might need a little bit of review on that, but most people were pretty good at that once they practiced. So there's those questions. Now you have to be able to go backwards too. You have to be able to write names from formulas. And for this test, just worry about ionic. Don't worry about covalent naming. Just worry about ionic. So when you name a compound, the first thing you want to do is name the cation. So you check and see if it's a transition metal. And calcium is not, because it's not in this middle yellow section. If it's not a transition metal, you just name it its normal name. And then for the anion, the second part, you just change the ending to "ide." So oxygen becomes oxide. So this is calcium oxide. And that's it. It's super easy. Let's do K2CO3. K is not a transition metal, so we're just going to call it potassium. Now my anion is more than one type of element. It's C and O, so that tells me, oh, it's going to be a polyatomic ion. So I better look it up. And I look it up and I see that it's carbonate, CO3. So that's going to be potassium carbonate. And then finally, here's where it gets a little tricky. Titanium is a transition metal. So what that means is that it needs Roman numerals. So I'm going to write titanium, and I'm going to leave some parentheses. And I'm just going to leave those for a second. I'm going to name the second part. And we know that O is oxide, because we already named it in calcium oxide. So this is going to be titanium oxide. Now, the charge of titanium is going to depend on the charge of oxide. So we need to look at oxygen and see what charge it has. It's a -2. Okay, we also need to think about how many titaniums I have and how many oxides I have. So this formula is telling me that I have 1 titanium, and I will always have 1. If the formula says 1, it's just 1. It's also telling me I have 2 oxides. So these 2 circles represent the oxide, and the oxide is -2. We looked up on the periodic table. So overall, that negative charge, if I add those together, that's -4, right? 4 minus. And I know that my 1 titanium has to balance out that negative charge. So it's got to be a 4 positive. So it's going to be IV, because IV is 4 in Roman numerals, okay? So again, you might just need a little bit of a refresher on that. We've got lots of nice practice problems for you on how to do